This machine didn't end up here for looks, and it sure didn't come for an easy ride. Sitting in front of the crew is a mountain of heavy steel that, not long ago, could have passed for a dead machine, worn out and done after a hard life. But nobody here sees it that way. Here, this isn't the end. This is the start of a huge, brutal, expensive rebuild, where every move has to be dead on, because mistakes in a job like this don't weigh pounds. They weigh tons. At first, the whole thing looks almost unreal. Massive parts are jammed tight inside the container, like the steel itself doesn't want to come out without a fight. Every piece is heavy, awkward, and has its own balance point and its own attitude. Swing the crane a little wrong, jerk it too hard, miss the angle, and one problem instantly turns into two. So nobody rushes. Nothing here is done sloppy. First they think, then they hook it, then they pull slow. Only after that do the first pieces of this future machine start coming out into the open, and the second that first heavy section starts sliding out of the container, you can tell this is serious. This is not some quick fix or ordinary teardown. They're literally rebuilding a giant working machine piece by piece. Every component is so massive it has to be treated almost like its own separate machine. One guy keeps the line steady, another guides it, another watches to make sure the load doesn't drift, and somebody else is already thinking ahead to where that part needs to go next. In work like this, nobody is extra. Everyone matters, because one bad inch can turn into hours of rework, more money burned, and a whole new set of risks. Little by little, more heavy steel comes out, and the yard starts filling up with parts that still don't look like one machine yet. But that's only at first glance. What's really sitting here is a complete working system. The base, the swing parts, structural sections, lever arms, hydraulics, big body panels, frame pieces. Right now it's all separated, but every single part is already waiting for its moment. Later, all of it has to line up down to the millimeter, sit on the right axis, hit the right angle, and start working like one living system. The heaviest assemblies grab attention right away. Those are the parts that will carry the real weight, the real force, and the whole working attitude of the machine. Nothing here is random. If the base is weak, if the swing section is crooked, if the metal is tired, if the joints are worn out, then there's no point pretending everything will be fine. A machine like this will quickly remind you that power loves precision, not lazy work. That's why every major piece gets pulled out, laid down, checked over, and only then cleared for the next step. The steel on these parts has clearly been through a lot. You can tell this machine didn't come fresh from the factory or out of some glossy brochure. It carries the marks of hard work, old loads, scuffed surfaces, fatigue, and that look only real working machines get after years in dirt, mud, pressure, and zero mercy from the job. But that's exactly the whole point here. This isn't some new toy. It's a working beast that needs its shape, strength, and purpose brought back. While some of the crew keep pulling out more parts, others are already studying the mounting points, the lower assemblies, the seating surfaces, the places where everything will eventually meet. And this is where real engineering discipline starts. Because with heavy equipment, it's not enough to just have all the right parts. They also have to be brought together the right way. Without that, nothing will work the way it should. Big Steel does not forgive freelancing. It shows you immediately who actually knows what they're doing and who's just faking it. Then the boom shows up, and everything instantly gets more intense. There it is, the real working backbone of the whole machine. Not some decorative piece, but the main lever where all the force will run through later. This is what will lift, drop, pull, shove, press, and send the full strength farther down to where the machine meets the ground. If there's a mistake here, everything after this becomes pain. So the boom doesn't just get thrown into place. They walk it in slowly, keep it hanging, level it out, find the position, and keep checking how it sits against the base. Then the hydraulic cylinders show up, and right away, it's obvious the job is moving into another league. Now it's not just about putting the shape together, now they're building motion. Hydraulics are what will bring all this heavy steel to life. Without them, the boom is just a giant dead chunk of iron. With them, it becomes a real working tool that can lift, swing, and do the hard job this machine exists to do. But hydraulics don't love brute force. They love accuracy. If the cylinder goes in crooked, if the axis is off, if there's extra stress left in the joint, everything starts dying way too early. The rod won't track right, bushings start getting eaten up, seals give up fast, and instead of a working machine, you get a very expensive headache. That's why every one of these connections gets assembled with a level of attention that might not even be obvious from the outside. It's not just about getting it installed. It's about the right line, the right seat, and the right behavior under real load later on. And that's the beauty of heavy mechanics. From the outside, everything looks rough, huge, and brutally heavy. It feels like the whole thing depends only on weight and steel. But the truth is, all that power depends on tiny details most people would never even notice. One pin, one bushing, 1 millimeter off, one wrong angle. That's all it takes for a multi-ton system to slowly start destroying itself. That's why this work is done not just with hands, but with judgment, visual feel, and real experience. The boom hangs from the crane while the crew carefully brings it into place. Guys below steady it with their hands and call the signals. The part moves slow, heavy, stubborn, and in moments like this, you really see how much real work is going on. No push-button magic. No clean, shiny fantasy. Just crane, steel, hands, tension, and the constant fight to make giant parts line up the way they have to. And when things finally start to come together, when the holes finally catch the same axis, when the steel stops fighting and settles into position, that's when the feeling hits that makes jobs like this worth watching. Chaos starts turning into order. Little by little, the familiar outline starts showing up stronger. You can already read the machine's character. The base is carrying the load. The boom is taking its place. The hydraulic cylinders are getting their mounting points. The upper section stops looking like a pile of parts and starts looking like a real working structure. And the farther the assembly goes, the more you can feel that this is no longer just iron being moved from one place to another. This is function coming back. Not shape for the sake of shape, but the real ability to work again. Then attention shifts to the power side. And this is where it gets clear that outside assembly is only half the battle. Because without a proper heart, this whole heavy structure is just a giant skeleton. The engine, the pumps, the lines, everything that feeds the hydraulics and motion has to be put in order just as seriously as the outer assemblies. You can't build a good-looking shell and hope that's enough. A machine doesn't live off shine. A machine lives off everything inside working the way it should. The power section makes one thing obvious right away. Internal discipline matters. Weak spots can't be ignored here. You can't just hope old equipment will somehow fire up and be fine. If there's a problem inside, it'll show itself immediately. And not when it's convenient either. It'll show up once the machine is already under real load. That's why the power side deserves the same respect as the boom or the base. Without it, the whole build loses its meaning. Then it's time for the upper panels and the cab. And that is not some minor detail either. The operator's station has to be installed right, not just dropped into place. The cab means visibility, control, safety, and the ability for a person to work inside this thing for hours without fighting the machine. A badly mounted cab doesn't just look crooked, it creates a bad seating position, discomfort, poor visibility, and extra problems in day-to-day use. That's why it gets lifted, moved, and set with planning, not luck. When the washdown starts, the whole look of the metal changes. Old dirt, dust, buildup, and leftovers from its past life get blasted off, and the surface starts telling the truth. That's when the real signs of age show up better. Where the metal is tired, where there are leaks, where the machine still carries its old working scars, and where things are still holding on strong. On a job like this, washing isn't cosmetic. It's how you see reality. And clean metal, no matter how you look at it, always tells the truth better than dirty metal. After the wash, the machine reads differently. Not because it suddenly looks pretty, but because it finally makes more sense. Now it's easier to see what's ready for the next stage. what still needs attention, and what can safely go back into the larger system. And this is where quality is born. Because the better you understand the condition of every surface and every assembly, the fewer surprises you're going to get later. Then comes the heaviest and most atmospheric stage. The work keeps going after dark, under artificial light, and right there, you can feel the real rhythm of production. Nobody is putting on a show, they're simply pushing the job forward as long as the machine, the crew, and the opportunity allow it. Night work on something like this means the goal isn't a pretty process. The goal is a real result. The machine has to come together, it has to get back into service, and it has to become useful again. A heavy block shows up under the crane, looking like a counterweight or a major rear structural section. And now the whole conversation becomes about balance. On a heavy machine, nothing holds together by itself. When the working end moves forward, something has to balance that mass from the back. That's exactly what the counterweight does. Without it, all that front-end power can turn dangerous fast. So this isn't just some chunk being bolted on to complete the look. It's what gives the machine stability, calm behavior, and the ability to work without feeling like it wants to dive forward. They bring it in slowly, very carefully. The crew watches the gaps, the flat planes, the distance to the mounting surface, because if a part this heavy goes in crooked, that mistake can cost you for a long time. Everything here weighs too much to allow careless work, so every inch gets checked, movement gets paused, checked again, brought in again, and only then do they keep going. By the time daylight comes back, the machine already looks completely different. Now, it's almost a complete system, and the work moves into the most delicate stage. It's no longer enough to just connect heavy parts. Now everything has to start living as one mechanism. Hydraulics are back in focus. Seating points, pins, and pivot joints take center stage. At this point, it's pure engineering accuracy. Earlier, the main job was to lift, move, and place the major assemblies. Now the job is different. Now the job is to make all of it move correctly. The hydraulic cylinder is brought to its mounting point. The holes find their axis. The connection has to come together straight, without force, without twist. And when the pin starts sliding into place, that's one of the most important moments in the entire job. Because now it's not rough assembly anymore. It's proof that the geometry was caught the right way. Proof that all the heavy work before this wasn't for nothing. Proof that this assembly won't just hold together, but will actually work the way it's supposed to. Then the front linkage starts coming together. The arm gets its place, connects to the boom, and gets fitted to its mounting points. And now the machine stops being just a big piece of equipment with a great silhouette. Now it gets real working mechanics. This is the linkage that will dig, pull, lower, raise, and do the actual work that machines like this are built, bought, repaired, and rebuilt for. And here it's especially important that the motion stays free but without extra play. Because play in heavy equipment is not just an annoying sound, it's future wear, impacts, damage, and money flying out the door for repairs. So every connection here has to be tight, accurate, and built with the future load in mind. The better it all sits right now, the easier this machine's life will be later. The lower half matters just as much. Tracks, supports, chassis, side structures, all of it carries not just the machine's weight, but its whole working character. An excavator doesn't just wave its boom around. It has to stand solid, move with confidence, hold its balance, and transfer all that load into the ground without weak points. If the base gives up, even a perfect upper structure won't save it. That's why checking the undercarriage is not just some box to tick, it's the foundation of the machine's whole future. The crew checks the chassis, side assemblies, the area around the tracks, the machine's overall stance, and how everything is holding together after assembly. There's no need for extra words here. Everything is already clear. They're not checking this machine for appearance. They're checking it for real work. It has to survive motion, load, dirt, rotation, lift, and the kind of punishment that turns an excavator into a real excavator instead of a statue. And the farther it goes, the more the main point comes through. This whole time, they weren't just assembling steel, they were building usefulness back into it. They were building the chance to put the machine back to work. They were rebuilding resource, the kind that later turns into actual working hours, money saved and money earned. Because new equipment costs a fortune, and if an old machine can be brought back the right way, that's not just a repair anymore. That's a full solution. That's a second shot without the insane cost of buying new. Now what sits in front of the crew is no longer a mess of separate parts. It's almost a complete heavy machine. The outer shape is there. The main assemblies are in place. The working linkage is tied together. The hydraulics have their connections. The base is carrying the load. The upper structure has its form back. And at this point, it becomes crystal clear what all of this was really for. Not for pretty metal, not for looks, but so this giant machine could become useful again. That's where the real power of the whole thing lives. Not long ago, these were tightly packed parts inside a container, heavy chunks of steel, scattered modules that couldn't do anything by themselves. And now they've become a complex working system again, one that has its purpose back. And that purpose is not to sit still. That purpose is to move, lift, dig, work, and deliver results where nothing smaller could do the job. This is what real heavy engineering looks like. No fake shine, no empty talk, no cheap show. Everything here is built on experience, patience, the ability to read metal, and the understanding of how it has to live under load. These giant parts get pulled out, lifted, washed, guided, lined up, fixed, and turned back into one machine, not because it looks cool, but because this is how equipment gets brought back to life when it still has something left to give. And when all of it finally comes together, one feeling stays stronger than anything else. This isn't just an assembled excavator. This is the result of hard, stubborn, very real work. Every effort here was for a reason. Every move was for resource. Every assembly point mattered because the goal was to make this machine become what it was built to be again: strong, working, useful. Ready to take on dirt, weight, and real-world punishment all over again.